This video goes over the concepts of finding the line of best fit and least squares regression. One thing to remember is that on the exam, you're only going to be asked to find the line of best fit and the correlation coefficient using technology. This lesson is going to focus on the background behind the technology, which can help you to interpret the results and double check to make sure that your calculator is giving you the right answers. So first thing that you need to be able to do is understand the regression line. A study was done to investigate the relationship between the age X in years of a young person and the time Y in minutes in which the child can run 1 kilometer. Data from children between the ages of 7 and 18 was collected. The equation of the regression line was found to be y equals 20 minus 1/2 x. Interpret the slope and y-intercept. So this is an example of a question where you have a regression line and you're asked to interpret the results. So here is the y-intercept. So that would be if the child was 0, they would run 1 kilometer in 20 minutes. That is meaningless. Okay. The other piece, okay, meaningless, what it means, we'll put that in here, that a 0-year-old could run 1 kilometer in 20 minutes. Okay. The second part is the slope. So it is negative, so it's falling to the right. So that means that as you get older, you can run faster. As you get older, you can run faster. Now, obviously, there's a limit on here, right? You can't run it in 0 minutes. It looks like the end, if you have 18, is the oldest person that they collected data on, you'd be running in 11 minutes, okay? So you should be able to interpret what the slope and the y-intercept means in a linear regression equation. The second thing that you should be familiar with is what a line of best fit is, so a trend line. You probably remember this from grade 9, but it's a line drawn on a scatter diagram to find the direction of an association between two variables. If you're drawing a line of best fit by hand, you want to make sure it goes through the mean point, which is the mean of the x values and the mean of the y values. Then you would find this point, then you would graph it, and then when you're putting on your line of best fit, you would just make sure it goes through that point with the other points evenly distributed about the line. You are really only responsible for being able to use technology to draw a line of best fit. So these are the steps that you need for your graphing calculator. You should memorize those. It comes up often on the IB exam. And we're going to look through an example below. So you can check out in the unit outline, there's a screencast of the steps on your GDC. But this is an example between instructional hours and then the driving test score for the instructor's students. And so the first question asks you to determine the equation of the line of best fit using your GDC. Following the steps above, you should get the line of best fit as y equals 1.17x plus 67.1. Okay. And then we're going to use so x is our instructional time and our student score is going to be y. So now we're going to use our equation to estimate what our driving test score would be if you did 17 hours. So here we would have y equals 1.17 times x, 17, plus 67.1. And let's see what we get here. So using your calculator for this part, you would do 1.17 times 17 plus 67.1 is going to give you 86.99, which we can round to 87.0. Okay, and if we look at our chart here, so 17 hours. So here's 15 and 85, and then 18 and 84. That puts us 17 and 87 kind of right in the ballpark. This next slide talks about least regression, which is one strategy used to find the line of best fit, actually what your GDC uses. Like I said before, you're not asked to replicate this on an exam. It could add some depth to your IA if you decide to pursue a stats topic. Okay, one piece of terminology that you need to be aware of is the residual. It's the vertical distance between a data point and the graph of a regression equation. The residual is positive if the data point is above the graph. The residual is negative if it's below the graph. It's only 0 when the graph passes through the data point, and the least squares regression line is one that has the smallest possible value for the sum of the square of the residuals. Here is the formula for finding the slope of a regression. See if I can get this to copy. I don't know why it's not letting me do that. Okay, so this right here, where n is the number of points. And so we know that the regression line must pass through the mean point. So we can find the equation of the regression by using the slope and the mean point. And we don't need to do that. Okay. So this is something that you can investigate if you decide to pursue a stats topic. Some interesting definitions, some interesting food for thought when it comes to finding linear regression, but you are not required to replicate this on an exam.